There we go. So in today's tutorial, we're covering probability at level 1. In this tutorial, the aim is to be able to describe probability in words, on a scale, and as a fraction. And your objective is to be able to show the probability of various events in words, as a fraction in its lowest terms, and on a scale. Describing probability first. So when we describe probability, we're talking about probability itself. We're talking about the chance that something will happen, or the likelihood of something happening, or how likely it is that that event will occur. And that's what the probability of it is. So we can describe the chance or likelihood of something happening using different terms. We can say it's certain, so there's events that are certain to happen. For example, time will not stop, the world will keep spinning, and if it's a Wednesday today, it's certain that tomorrow will be a Thursday. So those examples can be expressed as probability of certain. These are certain to happen. Can anybody else think of anything that's certain? I did have to get the team on this this week to try and think of different examples for these different scenarios. It's certain that we need air to breathe. There's all sorts of things that are certain events that will happen. We then have likely. So there's some events that are not certain to happen, but are more likely to happen than not. For example, if it's sunny outside, it is likely that I'll need my sunglasses today. It is likely that I will eat my lunch today. Yesterday I didn't, but today I did. So it's likely that I will eat my lunch today. And it's likely that it will rain somewhere in the UK this week. We can't say absolutely no way that it won't rain anywhere, but it's more likely that it probably will somewhere because we live in the UK and we have a mixture of weather, so it's more likely than not. We then move to the slightly other side of the scale, where we have unlikely. So the probability of an event or something happening that is unlikely or has a poor chance of happening. So it's unlikely that I will go on holiday this year. It's not going to happen. It's unlikely that I will catch the bus if I leave work late. So if I leave work late, I might miss my bus. I might not. If I run really fast, I can still get the bus. It's not certain unless I leave really late, I suppose. But it's unlikely that I will catch the bus if I leave work late. It is unlikely that I will get bitten by a swan on my way to work tomorrow. But I did once get bitten by a swan on the way to work. So it's not a certain or an impossible event. It's it's more unlikely than likely. On this particular day, I was walking to work along the canal and got approached by a family of swans. And I couldn't get past them, and I did get bitten by a swan trying to get past. So I ended up having to turn around to go over the bridge and back on myself a little bit. But it is not. You'd think it was impossible, possibly, but it's actually unlikely because it has happened before. And then we have impossible. So these are events that the probability of an event that is definitely not going to happen. So for example, to get anything but heads or tails when flipping a coin. It's impossible to get anything except for heads or tails. It's impossible if you roll a dice, you will get anything more than a 6. So you wouldn't get anything a 7 or more when you roll one dice. And it's impossible to turn back time. So the likelihood of time going backwards is impossible. So they're the 4 terms that we can use to express the probability of something happening. So let's have a go. What do you think about this one? So what's the probability of a bird landing on your head? Thinking about those 4 possibilities. What would you say? Pop your answer in the chat. Yeah, I'd hope so. So Chloe says unlikely. Yeah. So it's unlikely to happen. It's not impossible because it could happen. But it is unlikely that a bird will land on your head. What's the probability of the sun setting tonight? Certain. It is. The sun will certainly set tonight. What's the probability of 2 plus 2 totaling 5? Yeah. Let's hope everybody on the maths course gets this one. That's impossible. It's not going to happen. It can't happen. And what is the probability that it will rain at least once this month? Definitely likely. Even in June or July or August, it will still probably rain in the UK at least once this month. So there's just a few examples of how we can express probability in words. Now, what we can do as well, another way of expressing probability, and this is the type of question you might get in your exam, and I've got a couple of examples at the end. Oh, Maria's got a little problem seeing. Let's respond to Maria. So Maria, the recording. I know I can send it to one individual person. Sorry. A few people have joined us since we started as well. Obviously, if you want me to go over anything from the beginning, I can do. We've just discussed the different ways that we can express probability in words, which include certain, likely, unlikely, and impossible. We've just moved on to the section on probability scale. So this is another way of showing or expressing how much or how possible an event is likely to happen. So if you look at the scale at the bottom, no, what's that like from here? If you look at the scale at the bottom, it is a little bit pixelated, I apologise, but I thought this was a really good example of the scale itself. And you can, as I said, quite often get a probability scale as a question in an exam. You might get a blank scale, so if you look at the bottom one, you might just get the lines on the scale, and you might need to add the numbers. So if you look at the scale from the left to the right, we start with impossible is 0, so 0 chance of it happening. Halfway, we've got an even chance. And then all the way to the right, we have certain. So it's out of 1. So the possibility or probability of something happening on a probability scale is measured from 0 to 1, and anything in between that is a fraction of 1, which is a fraction on its own. So you can see that the one above that sort of shows in words, which is what we've already covered, where that place would sit on a probability scale. So if you look at impossible, the left, we've got them very unlikely, unlikely, an even chance, so about 50-50 is right in the middle, likely, very likely, and certain. And if you look at that bottom scale, it's included some probabilities of fraction there. So you can see in the middle, even chance is half, it's halfway. So express that as a fraction as 1 over 2 because it has half 50-50. It's half a whole chance of happening. Just check that. Oh, Fab Maria's back. Welcome back, Maria. Then we've got in between 0 and a half, we have a quarter because that's halfway between 0 and a half. And then that comes somewhere back between sort of very unlikely to likely. And then between a half and 1, a whole, we have 3/4 because that's exactly halfway between those. And then you can see that's somewhere between likely and very unlikely. So hopefully between these two scales, level 2 question could be similar to that. Pamela's just asked that question. But you probably need to, the question you would get would be a much bigger question, but you then might still have to answer it on a probability scale. So you could still have the same probability scale, but the question would be bigger. So you might have had to do more maths with fractions and things to actually get to the answer. Then he might ask you to express your answer on a probability scale, which I can show you how to do in a moment. I thought this was a really good way of showing the scale, which includes the fraction of something happening, alongside the wording to help you understand what it exactly shows. I've got a couple of examples as well. So this is another example I found of the probability scale, and it's got a few examples here as well. So again, we start with 0 to 1. So 0 is impossible and 1 is certain. Halfway between that, so you've got an even chance. So the example there, you've got getting heads on a coin, you've got a 50-50 chance, because when you toss a coin, you can get heads or a tails. There's only two different outcomes of tossing a coin. So you've got a 50-50 chance of getting a heads or a tails on the coin. Halfway between impossible and even chance, you've got unlikely. And the example there is winning the lottery. It's not impossible to win the lottery. People do. You're just not very likely because so many people play the lotteries, and to win is quite um, a thing in itself, I suppose. And then in certain, you've got the sun will rise in the morning. So again, right at the other end of certain, that's what you've got over that end as well. One other example coming up as well. In this one, we have the wording at the top, which is why I chose this, because I think it's a really good way of expressing the probability or the likelihood of something happening, showing the different ways you can express that. So you can express it in words. So you might say, in your exam, you might get a question, and then it'll give you 4 options. More likely to be impossible, unlikely, likely, or certain, and you would choose the answer to whatever the scenario is it's given. When you're moving on to level 2, and even at level 1, it will ask you to possibly express it as a fraction. Just like you can see here, it's expressed it as from 0 to 1, so 1 being a whole, and we've got 4 divots. So we've got a quarter, a half, 3/4, and a whole. And as you know, as a fraction, 4 over 4 is 1, is a whole. We never express a fraction as 4 over 4 because 4 over 4 is the same as 1 whole. But before that, you've got 3/4, a half, and a quarter. It's then expressed it and shown it as a decimal as well. So, for example, the chance of, what can we think? The chance of me having a break this afternoon is likely because I'm going to make sure it happens. So I would probably pop in there like the 3/4 chance of something happening. It's not certain because if I get lots of phone calls or have lots of work, I'll get drawn into another meeting again. I might miss my break, but it is likely. So you can see you've got about a 3/4 chance of it happening, which again is as a decimal is 0.75 and as a percentage is 75%. So probability can be expressed in each of those ways, and you'll notice in your BKSB learning that big module with fractions, decimals, percentages, ratio, it's all in there because they all mean the same thing. They're all related to each other. So if I asked you, what's the probability of a newborn baby being a girl? What would you say? You can express your answer in words, as a fraction, as a decimal, or as a percentage. What do you think? Nice easy one for you. Exactly. And everybody sort of express that in a different way. And you tend to find that, and I've probably mentioned this before, in fractions, decimals, percentages, we all have our favoured way of expressing something. I prefer percentages to fractions, and I even prefer decimal to fractions if I'm honest, because I can't see the size of a fraction quite often. But even as you've answered there, some people have answered with the percentage or the fraction or even in words. But it all means the same thing. Now, when you're answering a question about probability scale, you would possibly have a blank scale. Let me see if I can draw it. Can everybody see? Yeah, you can see that. You might have a blank scale like this. You might even have just 3 divots. It might ask you to create a probability scale as a fraction or as a decimal, but generally this is 0, this is a half, but again you can do 0.5 or 50%, and this is 1 or 100%. When it asks you to then represent the answer to a question, you would add a cross, just like I've done on the screen. So the probability of a newborn baby being a girl is 50-50. So you would then pop your cross in there. Now, if you had another question, like what's the probability that there are fish in the sea? What would you say? The probability that there are fish in the sea. Yeah. Yeah, even those first three, one certain, 100%, 100. Yeah. 100% chance. So again, just like that, you would add your cross here. And sometimes you might get more of a chance of something being likely to happen. So again, you just go halfway, because likely would stop about here, halfway between an even chance, a 50-50, and a 0% chance of happening. So you just pick on the scale where the probability lies. Now at level 2, you might be looking at the type of probability that is expressed as a fraction, but maybe as a third, for example. Now as a third, you would literally split your whole up, or your 100% if you want to look at it as a percentage, into threes. So you'd end up somewhere sort of here. So split into 3 equal parts-ish, a bit more here. About here is about a third. And you would place it where you believe a third would be, and there will be some leeway, obviously, for accuracy on that in your marking. Does everybody feel okay about probability scales? Anybody have any questions on that at the moment? Just trying to think if I've got another one. No. Yeah? Don't worry, if anybody's got any questions, just ask them, because I'm sure some. Yeah, I think. Does everybody have a preference? Do you think this is quite a good way of expressing probability? I think this is quite good. Yeah. Yeah, and I think, like I said, this chart I think that I found here is quite a good one, because it does represent it in a different way, and you could then use your strength as whatever maths you want to use, as a fraction, as a decimal, as a percentage, and you could still mark it in exactly the same place on your probability scale that you have. So what we can move on to now is expressing probability as a fraction. And this is generally how probability is expressed in a lot of the questions you get in your work, in your course, and on your test. You might be asked the probability of something happening. So the probability of something happening can be worked out by looking at the number of successful outcomes out of the number of possible outcomes. So if you look at what I've added at the bottom there, I've took that out of BQSB actually, because I think this is a really good way of writing it. So the probability equals the number of successful outcomes over the number of possible outcomes. See that division line there? That's literally your fraction. So this out of this. So say 2 out of 5. The possibility of something happening is 2 out of 5, as an example. It looks a bit strange, because if you don't like fractions, the probability can look a bit scary, but it literally means you write it as you say. So the chance of something happening is 2 out of 5, for example. I've got some better examples for you, obviously. So using this method, probability can be shown as a fraction. So if we were to roll one 6-sided die, how many possible outcomes are there? So this is the bottom half of your fraction. I'm sort of looking here now, but I've done a bit of sketching as well. How many possible outcomes are there of rolling a 6-sided die? Does anybody know? Yeah. Yeah, so there's 6 possible outcomes. So if you roll one 6-sided die and think of that probability, you've got 6 possible outcomes. So what is the probability of throwing a 4, or rolling a 4, do you think? Oh, got a few different answers there. So the probability of rolling a 4, so we've got 6 possible outcomes, and I think I've ruined it a bit here, but these are your possible outcomes for rolling a dice. 1, 2, 3, 4, 5, or 6. The possibility of rolling a 4 is how many times a 4 appears in the possible outcomes. So the probability of rolling a 4 is actually 1 out of 6. Because if you roll one dice once, there's only one chance you will get a 4, because you've got as much chance of getting a 4 as you have of getting a 1, a 2, a 3, a 5, or a 6 as well. Does everybody understand that? Do we think? Yeah, is that better? I think the numbers can quite often throw us a little bit, because if you think about it in, as somebody mentioned, if you think about it like 4 out of 6, it's not quite, because each outcome you have the same amount of chance that it will be that number. So you've actually got 1, and if you're not sure, you can always write down every possible outcome you can have. If I write down every possible outcome here, 4 only appears once. So you've actually got 1 in 6 chance of getting a 4. What about rolling a 2? Yeah. What about rolling a 2? What's the probability of rolling a 2 on a 1 6-sided die? Yeah, a couple of different opinions coming up there. But it is 1 in 6, because you've only got one possibility of that number being a 2. You've got exactly the same probability or possibility of rolling a 6-sided die of getting each of these numbers. So the chance, because the outcome, or the possible outcomes, is only once for each one, you've got exactly the same chance or probability of rolling each of these individual numbers as you have any of the others. So the chance of rolling a 5 is 1 in 6 as well, because you've only got one roll, there's 6 possible outcomes, and 5 only appears once. So you've got 1 in 6 chance of rolling any of these individual numbers. Now, what about the next question then? What's the probability of not rolling a 4? Anybody want to cater a guess? Yeah, I know what you mean, Halima. It's because we're looking at probabilities of fraction. This is where the numbers tend to come in as opposed to the wording. But you could still then take the probability of something happening, as in 1 in 6, express it on a scale. So you could literally make your scale down into sixths, which is about here. 1, 2, 3, 4, 5, 6. And the probability of getting a 1 or a 2 or a 3 or a 4 or a 5 or a 6 is about here. So the probability of getting that specific number that we want, which is a 4, is actually quite low, because you've only got 1 out of 6 chances of getting it. So this is a probability, if I just draw the die there, of getting one of these numbers with rolling 1 dice. So the probability of not throwing a 4 is, as correctly mentioned by many people, is 5 out of 6, because it's what's left of the fraction. But again, if you look at the possible outcomes, again, it's out of 6. Sorry. So not rolling a 4. So anything that's not a 4, you've got 1, 2, 3, 4, 5. 5 out of 6 chances of not rolling a 4. Any questions on that? Should we go over a different one? So what's the probability of not rolling a 1? So if the probability of rolling a 1 is 1 in 6, the probability of not rolling a 1, yeah, is 5 in 6. So if not a 1, so anything that's not 1, 1, 2, 3, 4, 5, is what's left out of the 6 options. I've got another example coming up. People joining. Hello to anybody that's joined us. I've got another example coming up here. This is the three-sided spinner. So if we look at, again, how many possible outcomes are there of a three-sided spinner? How many possible outcomes are there? Yeah. Yeah, there's three possible outcomes. So if you had a three-sided spinner, there's three possible outcomes. There's red, green, or yellow. So what's the probability of landing on red? Fabulous. Yeah. So 1 in 3 chance, because 1 out of 3 chance of landing on red. What's the probability of landing on green? Perfect. Again, 1 in 3. So what's the probability of not landing on a red? Exactly. Yeah, 2 in 3. So not a red. So take the red away. The other options is still out of 3 options altogether. Well, the probability of not landing on a red is 2 out of 3, and that's what's left. So that's your red, that's the green or yellow, or what's left. I'm not landing on the red. So how can we express that on a scale? It's just there. So you can see on the screen, the probability of landing on a red, the probability of landing on a green is both 1 in 3, which is about a third, is how we express that in words. So again, if we pop it on our scale, it's a third, which is about here. I would pop our X on the third section there. Any questions? Are we all okay? Fab. Just pop up with questions whenever you have any. Now, what I've got next is oh, hold on this question. So the probability of not landing on a green on the scale would be, so let me go back. So the probability of not landing on a green. So we've said the probability of not landing on a green would be 2 out of 3, because not green, you've left with 2 options, and that was 2 out of 3. So if you look on the scale, I'll do it on this one because it's not on that one there. If you look on the scale, you need a third, oh sorry, 2/3, which is a percentage of about 66.66 recurring percent. So you're looking for, if you split your bar into thirds, it's about here. So 2/3 will be about here. So the probability of it not green will be about 2/3 of the way. Not quite between the half and the 1, because if you remember, halfway between the half and the 1 is actually 75%, which is 3/4 and not 2/3. So if you're not sure and you need to split it up into thirds, you literally try and split this up into just the one long line into 3, and you're looking for 2/3, which is about here. But it's not quite halfway between. No problem, Tasneem. You can always ask a question. So we have to present the same fraction. So we have to represent the same fraction we got on the scale in the end. Just rephrase that question for me, Halima. I'm not sure what you mean. So basically however you find your fraction, so if it's 2/3, for example, as your answer, you'd find 2/3 on the scale and pop your x onto your 2/3. The one that I've put on the screen shows a third, which, to be sure if you're in about the right amount, it wouldn't be halfway between 0 and a half because that would be a quarter, and a third is more than a quarter. So you need a bit more than a quarter. If you split your long line up into 3, you'll end up with a third, 2/3 and a whole. So you should be able to map your thirds up as well. So I'll move on, but just let me know if you've got any questions. I can always go back. So what we have now, I have a bowl, a container. Sorry, let me go back again. It's all right, don't worry. A third, we have to put it in exactly before a half. You need to put your third in about where the third would sit. So if you think about splitting, let me try show this again. If you think about if you had, I'm sorry, I've probably not helped by putting so many marks on that original one. You might start off with something like this. So you'd have 0, 1. This is about halfway. So if you're looking at a third, you're looking at a third or 2/3 of this whole line. So you'd split it up into 3 about. That half's probably not in the right place, sorry. Split it up into thirds about, which is about there and there. So you've got equal thirds. So you've got 3 parts of this line. So 1/3 is about here. 2/3 will be about here. But if you imagine a half is going to be about here, and 3/4 about here, and a quarter is going to be about here. Does that help? Fabulous. So we can always go backwards. It's not a problem at all. So get rid of that. So we now have a container. So in my container, I have 4 red squares, 3 purple squares, 2 blue squares, and 1 green square. If I chose a square at random, what is the probability that I will choose a blue square? Have a think about your answers and pop you in the chats, and I'll just write a couple of bits up on here. 4 red. Perfect. Just give everybody a couple of seconds. No rush. Those that have answered, can you try and simplify your answer? Just give everybody else a chance to have a go as well. Perfect. Oh, you're good, aren't you? Does anybody else want to have a bash? I can go through it, obviously. Yeah, well done. So, if you think about how many outcomes we've got altogether. So, in total, in my jar, there are 4, 7, 9, 10 possible outcomes. What's the probability that I will choose a blue square? There's 2 blue squares. So the chances of getting a blue is 2 out of 10. Fabulous. Thanks, Joan. Now, quite often in your exam, it will ask you to simplify your answers. Now, we are correct in saying that the probability of getting a blue square is 2 out of 10. So 2 chances out of 10 altogether. But this can be simplified, and this is where we simplify fractions just as it is as a fraction normally. So to simplify this, you're looking at numbers that go into both, that you can divide the same number into both numbers to make it smaller. So in this occasion, we've got two even numbers. So if you have two even numbers, I probably always start by looking at any 2s or 10s that I could divide it by to make it a smaller number, both top and bottom. So to simplify 2 over 10, I would divide both by 2 to get 1 in 5, or 1 over 5. So the probability of that I will choose a blue square, a simplified answer is 1 in 5. The sort of basic answer, if you like, is 2 out of 10, but that's simplified then to 2 over 5. Sorry, 1 over 5, or a fifth chance. And if you think about 2 over 5, yeah, work it out however you'd like to. How do you work it out then, Pamela? Give us an example. You might have your own method for simplifying as well. And obviously, sometimes you will only be able to take it so far. If you end up with a prime number or an odd number that doesn't divide very well, you need to find something that I find something I can divide both the top and the bottom by. Yeah, yeah, that makes sense. So sometimes, hopefully, if you're quite good with your multiplication tables, which I do always mention, it is good to memorize if you can, because it can help you with that quick maths that you need. And eventually, you'll be able to see numbers and recognize straight away that, say, a 7 goes into both 21 and 49, for example. That's the sort of thing that can help you in your exam if you can. But recognizing that these are both even numbers is quite a quick way, and they're quite small numbers as well, so you can divide both by 2 to get 1/5. So what's the probability that I'll choose a red square? Do you know? Yay, it has been simplifying already. Fabulous. Yep. Anybody want to simplify as well if you can? So as always, we've got 10 possible outcomes. So out of 10, we've got 4 out of 10. Simplifying that, again, because they're both even numbers, you could divide the top and the bottom by 2. You could end up with 2 over 5. You can't take that any further because there's no number that will go into both 2 and 5. So the answer to what's the probability that I will choose a red square is 2 and 5, or 2 over 5. So choose 2 times 2 and 5 times 2. Yeah, you obviously have good recognition of your multiplication tables, Pamela. I tend to do it that way, but I think that's a habit of mine, I think, as well. Good. Right. So, sorry, any questions on that before I go move forward anymore? No, let me 2 seconds. Just turn that off. Okay. Great. Does anybody want to have a bit of a lottery while we're here? I'm going to choose one. Give me an option. What's it going to be? Beta, that's not a problem. Don't worry, I can send you the recording. What's it going to be? A lottery. It's purple. So it's still random probability as well. So the chance of getting a purple is actually 3 in 10, which you couldn't simplify because 3's prime. You can't get any lower than a 3. That's a lottery for you, isn't it? Nearly there. So what I've got next is an example from a non-calculator paper, an example from a calculator allowed paper. I do try and add these in when I can, but I try not to give too much away from your practice test as well. So this is an example of a level 1 non-calculator paper question on probability. So just as I showed you, the scale shows a probability that something will happen. If the probability marked is where it's shown on that scale there with the arrow, what option would you give as an answer? Just pop in the chat box A, B, C, or D. Are we sure? That's okay. um, yeah. So if we look at it, we just need to make sure we're along the right. So think 0 to 1. So there's 0 chance of something happening, and 1 being 100% of some chance of something happening. So if the scale is in the middle, like that, Palmer's getting all excited about probability. If the scale, if it's marked about here, which is where it is on the example, this will be likely. This will be certain. This is about a quarter of the way, will be unlikely. This would be impossible. So the answer there would be D, likely. Now what I've got at the end, this is an example from a calculator allowed paper at level 1, again, because we're just doing level 1 today. I'm going to let you have a go at it yourself. I can send you the presentation to do, so you can have a go at it and have a look at it properly, because we're getting time sort of ticking away on today's tutorial as well. But if we have a read through, so a workplace gives one raffle ticket to its workers for each sales target they meet. Each month, one ticket is drawn at random for a prize. The chart shows the number of sales targets met by each worker. What is the probability that Jim will win the April draw? Complete the table probability diagram below and show your answer. Yeah, that's fine. And I recognise that on the screen, obviously, it's a little bit smaller. So I'm going to send this presentation over to everybody so you can have a go at this question in your own time. Obviously, send me some answers if you want to. It's totally up to you. You don't have to. But this is a good example of where you might have to do a little bit of something else before you actually express your probability on your scale. And that's a good example there on the screen of the type of scale you'd get. So as I mentioned, you have blank boxes and then it's marked halfway. So you'd have to show your 0 and your 1, and then you'd mark your probability on the scale itself. Yeah, no problem. So I'll send the presentation over. I'll try and send it over this afternoon, actually. It might be a bit easier. Does anybody have any questions on probability at the moment? Is everybody okay with what we've covered today? Just pop in the chat yes or no. That'll be fabulous. Yeah, the Chloe just mentioned the exam question always makes it look harder. I do know what you mean. I can go over this question if you want to. It's not a problem. It's just and I think as for every learner that I've ever had go through maths, for example, as an exam, there's this little bit of this gap between coming off your learning on BKSB, because on BKSB and all your learning is split up into individual modules, isn't it? So if you're working on fractions, you know you're working on fractions. What you've got to then be able to do is apply everything that you've learned from BKSB in your learning, and then answer some questions that could be this example for this question includes reading information from a graph, putting your answer in probability scale, showing your working. Now, if it says showing your working, there will be marks available for that. So even if you got the wrong answer, you show all the working that you can, and you put that graph, that chart, as the best you can. It could be worth maybe 3 marks, this one, 4 tops. You could still get 2 or 3 marks though, even if you get the question wrong. So it's that thing of being able to then take all this new information you've got and then apply it to a question where you might have to bring a couple of different pieces of maths together to then answer the question. And that's where we'd like to do quite a few practices. As you know, you need to pass 2 practice tests to be put forward for your exam. That's to give you the confidence that you're ready, and also to give us the confidence that you're ready. There's nothing worse than getting a fail, and then it can knock your confidence completely, and then it's a job in itself to then get you back on track. So we like to make sure you're ready, and obviously you only want to go through that exam scenario once for most people, because it's not the most pleasurable day of your life, is it? A maths exam. So I'll send this presentation over. Does anybody else have any questions? Pamela would love to take the practice test, and she's just waiting for me to email them to her. I will do, I promise. I'm showing you a glimpse of a couple, Pamela. So just let me double check the chat. So just decided you need more practice. We can start off some more practice if you want to. Have you been over that section on your learning yet, Jatisai? On probability? Maria's asking for tree diagrams next week. Maria doesn't like me. No, I'm joking. We've already had this conversation, Maria. I don't like a tree diagram, but we can go over it, I'm sure. And like I said, we can do probability level 2 a bit more next week, which will include a tree diagram. I'll try and set something up. I think we should do, to be honest. Follow this on. Level 2 tree diagram.